Hey, welcome back. So we're going to do Chapter 6 warm-up, which is talking about standard normal probabilities, and in this case we're also going to look at something called a uniform probability. So, first, for the first example, let's say that we never check the time that we leave the house, and we randomly have to catch a bus. So what's going to happen is that the bus is going to arrive every 10 minutes, and we have an equally likely chance of catching the bus at any moment we leave. So this is called a uniform probability. So one thing I'd like to point out is that the bus arrives every 10 minutes, and we have an equally likely chance of catching the bus at any moment. So, first off, what is the probability that we have to wait between 0 to 10 minutes? Well, that is all of the possibilities. So, the probability that we have to wait between 0 and 10 minutes has to be equal to 100% or 1. Now, here's the deal, is that we have an equally likely chance of catching the bus at any moment. So what that means is that all of the probabilities for all the different times that we're going to have to wait are going to be the same. Well, if all of these probabilities have to be the same, but they also all had to add up to 1, well then what this is going to look like is it's going to look like a rectangle. So the reason it looks like a rectangle is because if we're like, hey, what's the probability I have to wait 1 minute? Well, the probability I have to wait 1 minute is going to be 10% because it's 1 divided by 10, the total amount of minutes that we have to wait. So this would be a case of a uniform probability. Notice that lately we've been using normal probabilities where not everything is equal, it's split up, so you're more likely to see things around the mean than you are far away from the mean. So for the next problem, let's say we want to know what's probability we have to wait between 3 to 6 minutes. So when we're figuring out probabilities, they're going to be the area under the probability curve. So if I want to see the probability I have to wait between 3 to 6 minutes, I have to find the area under the curve in between those two times. Now this isn't going to be that bad because the base of this is 3, and the height of this rectangle is 0.1. Remember, because they all have to have the same probabilities, and all their probabilities have to add up to 1. So the probability we have to wait between 3 to 6 minutes is going to be 3 times 0.1, which would be 0.3 or 30%. Now, let's use this distribution above to find the probability that we have to wait between 2 to 7.5 minutes. So again, that probability is going to be the area under the curve. So we have to find the area under the curve between 2 and 7.5. So we have to find all this area. So when we're finding all that area, our base now is 5.5, and our height is still 0.1. So the probability we have to wait between 2 and 7.5 would be 5.5 times that 0.1, which would give us 0.55, or we'll have to wait that long 55% of the time. Okay, great. Alright, here's something that we're a little bit more used to. So, suppose that IQ scores have a distribution such that n of 100, 20. So remember that n tells us it's normal. The 100 is our mean, and the 20 is our standard deviation, or sigma. So what is the probability that a person has an IQ of 83 or lower? Draw a normal distribution and shade in the area where these people would fall. So most people are going to have an IQ of 100. Some are going to have an IQ a little bit higher. Some will have one a little bit lower, a little bit higher still, and a little bit lower. So we want to find the probability that somebody has an IQ score of about 83 or lower. So remember, whenever you're trying to find probabilities, the first thing you have to do is find the z-score. So that'll be 83 minus 100 divided by 20, and that will give you a z-score of 0.85, but don't forget it's going to be negative. Remember, we know it's going to be negative because it is less than the average. All right, now what we're going to do is we're going to pull up our z-table and find that z-score. All right, so now that we've pulled up our z-table, let's try to find that z-score. So let's see, we need to find negative 0.8, and then we have 0.5. So that is going to give me a z-score of 0.1977. Which is the same as 19.77%. Now the next one asks, what is the probability a person has an IQ of 115 or higher? So again, if we draw that normal probability, we're looking for 115 or higher, so that's going to be from here over. So again, the first thing we need to do is find the z-score. So that's going to be 115 minus 100 divided by 20. Now remember, your z-score should be positive because it's a little bit bigger than the mean. So when we calculate the z-score out, we are going to get a positive 0.75. Now, when we find that probability on our z-score table, remember, the z-score table only gives you the area to the left. So if you want to find the area to the right, what you have to do is find that probability and then subtract it from 1. So 0.75 is going to give us a z-score of 0.7734. But remember, we have to subtract that from 1, because what that 0.7734 is that's this probability over here. We have to figure out what this probability over here is, and that's why we have to subtract it from 1. So when we take that number and subtract it from 1, what we are going to get is we're going to get 0.2266. Okay, so just a reminder, this area here is at 0.7734. To find the other area, we had to subtract it from 1. Now, the last question asks, what's the probability a person has an IQ between 78 and 107? Okay, we want to draw a normal probability and shade in the area where these people would fall. So, first, we're going to have 100 here. So 78 and below would be here, and 107 and below would be right here. So what we're interested in is the difference between the two. So what we're going to do is we're going to find the z-score for both. Come in. Hey, baby. Alright, so you might have noticed that there was a weird edit, and that is because a very sweet little girl came into my bedroom. And what did you need, sweetie? You needed juice, because why? Because your throat was so dry. It was so dry. Okay, well, she's going to stay outside and see what Dad's doing, because Dad couldn't get her juice. Only Mommy can get juice. So my apologies. So we're going to find the z-score for both of these. So once we find the z-score for both of them, we're going to get a z-score of negative 1.1 for this one. And for the other one, we're going to get a z-score. We're going to get a z-score of 0.35. Now, after you find the z-scores, you're going to find the probabilities straight from the table after this. we're not going to subtract them from 1 or anything like that. So the z-score for negative 1.1 is going to be 0.1357. And the z-score of 0.35 is going to give us a probability of 0.6368. Now, visually, I'm going to show you guys what we just found. So, visually, what we just found is we found this probability here is 0.1357, and we also found this probability here is 0.6368. So if we want to find the probability that lies between them, what are we going to do? Well, we're going to subtract the two. So remember, you're always going to subtract the bigger number and then the little number. So the little number from the bigger number is what I should say. The reason you have to do that is because, remember, probabilities cannot be negative. That makes no sense. So we are going to get an answer of 0.5011. Awesome. Now, let's say that we wish to find the IQ score for which the score will be in the 60th percentile. Oh, so since we're looking at the 60th percentile, that tells me that we're going to have to work backwards. So again, we're going to have to go back to our z-table. And remember, we're going to be looking in the center part, and we're going to try to find a value that's close to 60%. So when I look at this, I can see a value kind of close to 60%. It kind of looks like maybe this one right here, which I just covered up. That's great. So anyway, that would be a z-score of 0.26. So z equals 0.26. Now what I have to do is I have to work backwards using the z-score formula to find the actual IQ score. So I know the z-score is 0.26. I don't know the x value, that's what I'm trying to solve. I do know that the average IQ score is 100 and the standard deviation is 20. Now I just need to solve for x, so I need to multiply both sides by 20. Those will cancel out. I get 5.2 equals x minus 100. Add 100 to both sides. And that IQ score will be 105.2. So if a person has an IQ score in this example of 105.2, that means that they would be in the 60th percentile. Okay. Very last question. We wish to find the IQ score of which 25% of the population will be that score or higher. So 25% will be that score or higher. So that means we're looking at the upper 25%. Okay, so here's the deal, is that the upper 25%, or finding the score that's associated with that, is the same thing as finding the score that's associated with the lower 75%. So we're going to do the same thing we did in the example above, only we're going to be looking for that 75%. The reason is because our z-score table only gives us the area to the left, but not the area to the right. So let's see, if I find one that's close to 0.75 in the middle, I think this one looks pretty good. So that's going to be a z-score of 0.67. So now I'm going to use that to find that x value. So x minus, remember we know the average is 100 and the standard deviation is 20 because they gave it to us in the problem. Now we're going to do the same thing, multiply both sides by 20 and then add 100. So 0.67 times 20 plus 100 gives us an x value of 113.4. Great. Now, just a little reminder is if you go to StatCrunch, you can check all of your work on StatCrunch. So you're going to go Stat, Calculators. Remember, we're looking at normal distributions. Okay, and we can check our answers here. So let's go ahead and check this answer for number 3. What is the probability a person's IQ will fall between 78 and 107? So remember, we have to change the mean, which for our problem was 100. Standard deviation was 20. And remember, we want to do between, so we have to highlight that between up there. We want to see what the probability is between 78 and 107. So when we do this, we get 0.5011, which is actually exactly what we got when we did it by hand, which is wonderful. Now, let's say we want to check our work on this one. So StatCrunch doesn't let you reverse percentiles. However, if somebody's in the 60th percentile, that means that the 60% is going to be the area to the left. So let's go ahead and check this out. So let's go back to the standard view. And let's plug in our answer and see if it actually equals around 60%. So let's plug in 105.2. And look at that, we get 60.25%, which is very close. For the last one, let's check and see if 113.4 actually does give us a IQ value such that 75% of people scored lower, or another way to say that is that 25% scored higher. So 113.4. 78.85, that's about 75%. Wonderful. All right, I hope you guys found this video useful.